Welcome to the new era of video creation with Bayozi 8. This is our new series on AI teaching natural language processing. Today, we will discuss the sentiment analysis presentation. Here are the contents. Sentiment analysis is the computational task of identifying and categorizing emotions, opinions, or attitudes expressed in text. It has become a cornerstone of natural language processing, NLP, and is used across many industries to gauge public sentiment, improve customer service, and understand market trends. For example, sentiment analysis can be applied to social media posts, product reviews, and customer service interactions. The key sentiment categories are positive, negative, and neutral, but some systems also classify text as mixed if there are conflicting sentiments present in the same text. The main challenge in sentiment analysis lies in processing large volumes of unstructured text and extracting meaningful sentiment information. It's not only about recognizing positive or negative words, but also about understanding context, tone, and sometimes even sarcasm or irony. Sentiment analysis is a powerful tool that helps businesses and organizations scale their ability to understand customer feedback automatically. Sentiment analysis has become incredibly valuable in today's data-driven world. Here are some of the key benefits. Customer feedback analysis. Companies can use sentiment analysis to automatically analyze thousands of reviews or survey responses to identify areas of improvement, spot trends, and understand what customers love or dislike about their products. Market insights. By analyzing sentiment, companies can better understand the shifting landscape of customer preferences, track the success of marketing campaigns, and predict future trends. Brand management. Social media and online reviews play a crucial role in shaping brand perception. Sentiment analysis helps companies monitor public opinion, address potential issues, and enhance their brand image. Marketing and advertising. Marketers can adjust campaigns based on public sentiment, targeting specific emotional triggers, and engaging with customers in a more personalized way. For instance, positive sentiment in certain regions can be leveraged to boost marketing efforts. Overall, sentiment analysis is an essential tool for companies looking to stay ahead in a competitive market. Sentiment analysis can be approached in several ways, each designed to meet specific needs. Fine-grained sentiment analysis. This is the simplest form of sentiment analysis, where sentiment is classified into broad categories such as positive, negative, neutral, or mixed. For example, the sentence "I love this phone" would be classified as positive, while "the phone's battery is terrible" would be negative. Aspect-based sentiment analysis. Here, the focus is on analyzing the sentiment regarding specific features or aspects of a product. In a review like "the camera quality is excellent but the battery life is disappointing," the sentiment analysis system would categorize sentiment separately for the camera, positive, and the battery, negative. Emotion detection. In addition to sentiment, this approach identifies specific emotions expressed in the text, such as joy, anger, fear, or sadness. This is particularly useful in applications like customer service or mental health analysis, where understanding the emotion behind the text can drive better responses. Sentiment trend analysis. This method tracks sentiment over time. For example, you could use sentiment trend analysis to monitor how sentiment surrounding a movie evolves after its release, or how a political campaign affects public opinion over several months. Each of these types of sentiment analysis provides different insights and is tailored to specific objectives. Sentiment analysis faces several challenges that can make accurate classification difficult. Ambiguity in language. The presence of sarcasm, irony, or humor can complicate sentiment analysis. For example, the sentence, "I love waiting in long lines," seems positive grammatically, but is clearly negative in meaning due to sarcasm. Domain-specific language. Different industries use specialized vocabulary that sentiment analysis models may struggle to interpret correctly. For instance, in healthcare, terms like chronic or acute may have a specific connotation that differs from everyday language. Thus, domain adaptation is needed. Neutral or factual statements. Sentiment analysis models often struggle with neutral or factual statements. For example, "The phone weighs 150 grams" isn't expressing sentiment, but it's often mixed with sentiment-laden reviews. Mixed or conflicting sentiments. A review might express both positive and negative sentiment. For example, "The phone's camera is great, but the battery life is terrible." Analyzing these conflicting sentiments is tricky and often requires sophisticated models to handle such complexities. These challenges highlight the need for more advanced models and techniques to improve accuracy. There are several techniques used to perform sentiment analysis. Lexicon-based approaches. These methods rely on predefined lists of words with associated sentiment scores. For example, words like happy and love are assigned positive sentiment, and words like angry and hate are negative. This method is simple, but often too rigid, and doesn't handle complex language or context well. Machine learning-based approaches. These models use labeled datasets where each piece of text is tagged with its sentiment. Machine learning algorithms like naive Bayes, SVMs, or logistic regression are trained on these datasets to learn the relationship between the text and sentiment. This approach is more flexible than lexicon-based methods and can generalize to unseen data. Deep learning-based approaches. In deep learning, models like RNNs, LSTMs, and transformers, e.g. BERT, can learn more complex patterns in data. These models are particularly powerful when large amounts of labeled data are available and can handle nuanced language features. Hybrid approaches. Some systems combine lexicon-based methods with machine learning or deep learning to benefit from both approaches' strengths. This can help overcome some limitations of each individual technique. In lexicon-based sentiment analysis, the approach depends on sentiment dictionaries or lexicons that assign a sentiment value to each word. For example, the word great would have a positive score, and horrible would be negative. This approach is simple, interpretable, and fast, making it suitable for situations where quick results are needed. However, it has significant limitations. Context. Lexicon-based methods don't account for context. For example, not good might be misclassified as positive, because good is positive, but the not negates it. Sarcasm. It struggles with sarcasm and irony, as these features require contextual understanding that lexicon-based systems can't provide. Coverage. Lexicons are often incomplete and may not capture all relevant sentiment terms, particularly domain-specific terms. Machine learning-based approaches are more sophisticated and adaptable. They rely on labeled data where each piece of text has a known sentiment, which the algorithm uses to learn how to classify new text. Popular algorithms include support vector machines, SVMs, naive Bayes, logistic regression. These models work by extracting features from the text, such as bag of words or TF-IDF, term frequency inverse document frequency, which represent the frequency of words in a document and their importance across a collection of documents. The advantage of machine learning-based methods is their ability to generalize better than lexicon-based methods, especially when dealing with more complex, diverse text. However, they still require labeled data for training, which can be expensive or time-consuming to obtain. Deep learning-based sentiment analysis represents the most advanced approach. Recurrent neural networks, RNNs, and long short-term memory networks, LSTMs, were originally popular for text analysis due to their ability to capture the sequential nature of language. More recently, transformer-based models like BERT and GPT have revolutionized sentiment analysis with their ability to understand context more effectively. One of the key advantages of deep learning is that these models can automatically learn features from the data, eliminating the need for manual feature engineering, which is required in machine learning approaches. This allows them to capture more complex and subtle language patterns, such as sarcasm, negation, and irony, which are difficult for traditional models to handle. However, deep learning models require large amounts of labeled data for training, and they are computationally expensive to train and deploy. Hybrid approaches seek to combine the strengths of lexicon-based methods and machine learning models. In these systems, lexicons can be used to provide initial sentiment scores or features, which are then refined by machine learning models. This is especially useful when labeled data is sparse or when you want to achieve fine-grained sentiment classification. For example, you might use a lexicon to assign initial sentiment scores to words and then use a machine learning model to understand the overall sentiment of the sentence in context. Hybrid models help bridge the gap between simple, interpretable approaches and more complex, data-hungry methods. While traditional sentiment analysis focuses on positive, negative, or neutral sentiment, emotion detection goes deeper by identifying specific emotions in the text. Common emotions detected include joy, anger, fear, sadness, and others. This is especially valuable in applications such as customer service, where understanding the emotional state of a customer can help tailor responses. In mental health analysis, emotion detection can help identify when someone may be experiencing distress or sadness, providing better support. On social media, it can help detect public mood or reactions to events. Emotion detection is inherently more complex than traditional sentiment analysis, as it requires the model to go beyond simple classification to recognize deeper emotional undertones. Real-time sentiment analysis is crucial for businesses and organizations that need to monitor public sentiment and respond swiftly. For example, in social media monitoring, brands can track mentions of their products and quickly identify when negative sentiment spikes, enabling them to address customer complaints in real time. In customer support, sentiment analysis can help prioritize tickets, flagging emotionally charged interactions for immediate attention. Real-time systems also come in handy for live events or news monitoring, where sentiment trends can shift rapidly and prompt responses are required. To enable real-time sentiment analysis, the system must be optimized for fast processing with low latency, allowing quick reaction times to changing sentiment. Evaluating the performance of sentiment analysis models is essential to ensure that they perform accurately and consistently. Some key evaluation metrics include accuracy, measures the overall proportion of correct predictions. Precision, focuses on the proportion of positive predictions that are true positives. Recall, measures the proportion of actual positives that are correctly predicted. F1 score, the harmonic mean of precision and recall, providing a balanced view of model performance. Cross-validation techniques, where the dataset is divided into multiple subsets for training and testing, help ensure the model generalizes well across different data. A confusion matrix visualizes the model's performance across each sentiment category, showing how many instances were classified correctly and how many were misclassified. Evaluation allows you to assess whether the model is ready for deployment and performing well in real-world settings. Sentiment analysis has diverse real-world applications across various sectors. Customer feedback analysis. By automating the analysis of reviews or surveys, companies can quickly understand customer satisfaction and address pain points. Brand monitoring. Companies track public opinion on their brand, gaining insights into what consumers think and feel. Negative sentiment can be flagged for response, and positive sentiment can be leveraged for marketing. Political analysis. Sentiment analysis is used to monitor public opinion around political campaigns, issues, and events. This allows political analysts to gauge how candidates or policies are perceived. Market sentiment analysis. Traders and analysts often use sentiment analysis to predict market movements by analyzing the sentiment of news articles, social media, and financial reports. The future of sentiment analysis is filled with exciting possibilities. Deep learning models will continue to improve, leading to higher accuracy, better handling of context, and more nuanced interpretations of sentiment. Multilingual sentiment analysis will enable businesses and organizations to understand sentiment across different languages without needing separate models for each one. Reducing bias in sentiment analysis will be a key challenge. Models need to be trained and evaluated on diverse datasets to ensure fairness and reduce the risk of skewed results. Improving contextual understanding will be a priority, especially for addressing challenges like sarcasm, irony, and contradictory sentiments. In conclusion, sentiment analysis is an indispensable tool for businesses, researchers, and analysts who want to understand public opinion. As we've seen, there are several techniques available, each with its strengths and limitations. The field is evolving rapidly, with deep learning models and multilingual analysis driving the future of sentiment classification.